Welcome back. In the last video we have suddenly reverse engineered a more complex function. And now we want to insert real values. Afterwards we adjust our Java code and we will execute this function with these values and we will figure out if we have reverse engineered this function correctly. I didn't prepare this in this way, so I'm also super excited if this works out. So let's have a look. Okay, here we have our code. This is a more clean version of the code we have reverse engineered in the last video. It's the same code, but it's a little bit more clean. I try to improve my writing style that it does not get that messy in the future, okay? Alright, so we also have chosen some certain values for those registers. I mean, we just can influence these parameters. All other values will be calculated by itself. So let's see. We've got P1, which is 1. P2 is 3, 3, and P3 is 7. We are now going to emulate this function and execute this with these three values. And then we will figure out the return value over here. And afterwards we execute this function in our Android app and see if these values are equal. If this is the case, then congratulations. We have reverse engineered our first, more complex Smali application. I haven't prepared this, so I'm also a little bit excited on how good this goes right now. Let's have a look. Okay, so V0 is at this point 0. That's okay for us. V1 is at this point 2.3. Alright, now we've got V3, and V3 is now P1 plus P2, 1 plus 33. 1 plus 33. Okay, this means we've got 34. Alright, so let's see. We've got now V3, and V3 is 34 multiplied with 7. Alright, this might take a while. I will see you in a few seconds. Oh, never mind. So do not care about this one. Okay, so I have calculated V3 and V3 is 238. Was not that hard, to be honest. Alright, next we've got V3 and this one is now 238 minus 1. Let's see, yes, we can do this, 237. Alright, then we've got this one over here. Let's see, P1, which is 1. But it seems to simply get overwritten at this case. Okay, so we are not using this 1 over here. Then we've got V3 divided by P2. So we overwrite P1 over here with 200, no, what's V3? V3 is 237, that's correct. Divided by 33. All right, so give me just a second, I will do this again real quickly, just in my mind, and then we will come back. All right? Okay. For this case, I had to use the calculator, but so we could have done this on our own, but it's a little bit faster. So, okay, what do we have? We've got 7, 18, 18, 18, whatever. Okay, so P1 is, different. 7, 18, 18, 18, and I guess 2. I guess we shouldn't that be accurate on this one. Alright, then we've got V0. V0 was 0, we haven't used V0 so far. Okay, so we are reusing V0 at this moment. And this means V0 is now V3. V3 is still 237. Oh well, I knew there has this point where something goes wrong. Let's see how 207 XORed with this value, how good this goes. Alright, this needs to be done in our terminal because this will be a little bit messy otherwise. Let's have a look. So let's take this value over here, Python 3. Yes, that's a list, nothing we want to have. Alright, we have to use the dot. 237 XORed with this one. Yes, this is not working because we are using an integer and a floating number. I assume that this does not work. Let's see. I would assume, yes, the CPU or the program will execute this statement. It will cut off those floating point numbers. So yeah, at this point we cannot use floating point with an XOR. I was pretty curious about this, but yeah, maybe if we have two floating point numbers, then we can get the bit representation and we can do the math. But in this case, if we have int and float, then those floating point numbers will be cut off. And this is our result, 234. Okay, so 7.18.18.18.2. But in this case, this will be cut off anyway. So pretty good that we haven't been that accurate on this one before. So it doesn't really matter at this point. Okay, now our V0 is 234. And this will be also the return value over here in form of a double. That's it. Our function will return 234. Alright, so we will have a look into this in a moment. But for now I want to show you something because I struggled at a point a little bit. And this point was this one over here. Why? Because we've got p1 equals something, and p1 is a parameter and we have a value in our parameter, the value 1. So this confused me for a second, but by looking at this code I realized, okay, p1 is now being assigned a new value. This means the value 1 will be overwritten at this point. So we are not using the value 1 in this register anymore further in this code. We can see p1 has been used over here. There we have this value 1, sorry, let's do it this way. And afterwards we are also using it here, but here we are overriding it with this value. V3 divided by P2. So we do not have a statement something like this, 1 equals V3 divided by P2. Because the 1 doesn't matter at this point. We are reassigning this variable or this register over here. So we get a new value into this, and this value will be overwritten. All right. Simply just stick to the code as it is. And then you cannot make a mistake. I mean, yeah, okay, this is a really dumb message because you have to know what you're doing there and you also have to know what this instruction means. But if you overthink these functions and you bring on your own intentions what this instruction does, then we will make mistakes. Therefore, simply just stick to the instruction as they are in each line. And then, we cannot make a mistake. Okay? Okay, so let's look this value up, and otherwise I have to re-record this video and find the error which is in there. I really hope it is correct. So let's see. We've got the return value 234. Let's have a look. Okay, here we are now at the Ubuntu VM back again. We can see the math calculation over here. So let's open Android Studio. Tools, Android Studio, bin bash studio.sh. All right. So the GUI has been finished loaded. Let's have a look in the player code. And this is now super exciting. I will overlay our code with this one over here that we can see what our reverse engineering approach looks like and how the real code looks like. All right, there we go. This was the function. And this is what the original code looks like. Let's have a look at our code. All right, looks pretty good so far. The only difference might be regarding to the brackets and this multiplication factor. This is done in one line, but I mean, our CPU instruction also splits this up, or the assembly code also splits this up into several instructions. Therefore, pretty nice, pretty good job. All right, let's execute this code, and then we will know if our manual reverse engineering approach was as successful as our code analysis. Let's have a look. I'm also pretty excited. If I have to re-record this video, and if we have made an error, of course I will let you know about this. So let's see. We've got our player object already. So we can simply use player add power. And then we have to insert those parameters 1, 3, 3, 7. All right, and we need to print this value out. So we are using system out once again. Print line player Smally power equals, oops, this way. And we need this bracket at the end. Okay, let's make our connection to the virtual machine, our virtual device. Connect that. Okay, now let's run our application. So we go into run app, and please make sure that we are using the remote configuration. Within edit configurations, we can go into remote, this one over here. And here we have to enter the IP address of our system, and we also need to change the port to 5555. The default port in this config is 5005, but this one is the default ADB port. Okay, after doing this, we can click run and run app. We can also open our ADB logcat output, and yeah, there we go. Okay, one slight mistake. I will be absolutely honest to you. We are returning in double value, therefore we are not returning 234, we are returning 234.0. I guess, okay, to be honest, this was my mistake, okay? So I take the blame for this one. We have to make sure that regarding to the return values, we are also as accurate as possible. I guess, or I'm pretty sure this doesn't make a difference, or it might be. So regarding to type confusion or things like this. So for example, if we have an int and we rely on this, that we are having the number 234, but in real time we've got the number 234.0, which is double, then we cannot mix them up together later on in our code. So, okay. As already mentioned, I take the blame on me. This was my error. I'm super happy that I do not have to re-record this video right now. And yeah, I'm even more happy that we have successfully reverse engineered a more complex function based in Smally. So yeah, we didn't look up or even didn't look up the code once. This one over here. And if you take a look at this is a pretty amazing job. We are at the beginning of this chapter and we have reverse engineered this function. Okay, so you can really be proud of yourself. And yeah, this is a good point to move on with a little quiz. I mean, this quiz will be now maybe a little bit too easy for you, but nevertheless, we do this quiz and afterwards we patch our SpacePing application. We can now already enable some nice features. And yeah, I'm super excited to do this afterwards. But first, let's have a look at the quiz. All right, I see you there.